Hello, everyone. Imagine your family is going on a vacation to Paris. Now, they're very busy today because they actually got up late and the plane is about to go. And so they're in a hurry. And once in the plane, they actually thought about something they forgot. They forgot something very valuable. You. If it sounds something like you remember for a movie, that's because they made a movie about it. The movie is called, one sec. Yeah, Elena Hieme. Did I get it right? I still need to practice my Norwegian accent, but if you remember that movie, everyone saw the movie? Awesome. Okay, so now imagine you're a 9-year-old boy alone in a big house on Christmas Eve. And your mission is to protect this house from robbers. Now, what should you do? You don't have resources, you don't have money, you don't have time to install a big fancy alarm. What should you do? Basically, what should you do is try to come up with a plan to install something that is minimal with maximum efficiency. That's what we call minimum viable security. Wait, what? Really? Did I say minimum and security the same sentence in a crowd full of security experts? Damn, I did. Because if you think about it, you would believe that security needs to be the maximum, right? Well, maybe at some point it needs to be, but it definitely doesn't need to start with something that is maximal, because it's overwhelming. I mean, if now I'm starting a new project, what should I do? There's no standard, there's not a recommendation online, but definitely not something that you can just take as is and apply on your new cloud application. So what should you do? Well, basically, let me explain what I mean about it. I'm David Melamed. I'm the co-founder and the CTO at JIT, a startup that I started with a few friends actually a year and a half ago. I'm married with 4 kids, born in France but living in Israel. I'm passionate about security, cloud, and technology, and actually JIT is a little bit mixed about all of it. It tries to provide a way for developers to deal with security using some continuous security platform, but I'll get to that later on. So let's go back to Kevin. He's alone in the house, and these are the robbers. These are the attackers that want to attack him. So what would you do if you were him? Well, basically, you would start with a battle plan, right? You need a plan. And in the plan, you can see that there's a map of the house, and these are all some kind of security controls, right? So this is another view of his house, and you see that the first thing that he did is actually map all the entrance and the exits in the house. This is the ground floor, and this is the attic. Now, how does it translate in our world of technology? Well, this is my space. This is my public cloud provider, and my app is installed in the middle of it. And so if I need to map all the different entrants of my application, I will start with the attack surface that has public exposure to internet, right? All the public resources. It can be F3 buckets. It can be machines that have public IPs. It can be your public endpoints. And then I will try to look at the users that have access to the AWS console, for example. And so you have admin access, you have regular access, and what happens if their account is compromised? You also have your third parties. It can be Datadog for analytics. It can be Hexagon if you're using a serverless app that needs to be monitored. What happens if there's a breach there and they have access to your code and to whatever happens in your cloud? And finally, your app is also deployed in AWS in your cloud. And so what happens in the CI/CD pipeline. There's a lot of talk about supply chain attack. There also, if I'm using GitHub Action and someone is actually inserting some malicious code there, then I'm in danger. What should I do? And so, back to Kevin. What did he do? He had actually a lot of interesting booby traps. The first thing he tried to do is to lure attackers out, making them think that there's actually someone in the house. And then, because it didn't work, so he tries to make them go away by trying to shoot at them. And then he also tried to make the entrance slippery so that they wouldn't try to enter. And finally, he also make the doorknob so hot that you couldn't open the door. Did it work? Well, it actually stopped them, slowed them down, but at the end they managed to enter. And so the same thing on our cloud. What do we need to do? We need, first of all, to try to slow attackers down. And so if we're taking a look at the different areas that we've been talking about, the first thing you need to make sure is that you don't have any misconfiguration in your cloud. For example, any public bucket that you forgot about it. You need to have pen testing, making sure that your code is not vulnerable to SQL injection, for example. For your users, you don't want their account to be taken over. So let's make sure that they're using MFA. You need to ensure that. They also need to have only access to production if they really need to. So if there are admin duties, let's give them access to production. If they're not, maybe you shouldn't give them access to production. Also make sure that they're using different roles. For example, if you only need to check something, use a read-only role. You don't need the admin role for anything. So make sure you have granularity in your roles. What about your third party? Well, here again, make sure you're using MFA. No one can enter. And then if there's a breach there, make sure that you review the scope of the access that the third party has in your cloud application. For example, if you're installing an app that has all access to your Amazon, well, you better be ready that something can happen there if there's a breach, right? Same thing on your CI/CD pipeline. Usually, the scope is really wide there because it needs to deploy your application. And if you're using infrastructure as code, then even more, because it also needs to create some resources in your cloud. So you need to make sure that you're giving the amount of privilege that it really needs, and not more than that. And so how do I do that? Well, there's a few tools, and I will get back to that in a few moments, and I will show you how to automate all these tools very easily. Now, we've been talking about the perimeter, but that's only the first layer. Let's go to the second layer. The second layer is what happens with your app itself and the data it processes. So there are a lot of other threats that can happen. So first of all, your app is probably some inbound data. So there's inbound traffic and probably also outbound traffic. So this is one threat. There's also some user data, some maybe sensitive data. You may also have your own secrets. What should I do about it? Also in your app, there are different communication between the services. You're using microservices, so there's probably a lot of communication between them. But if you want to reduce the blast radius of an attack, make sure that you're not giving too much access to a service, something that it doesn't need. Now, you also have libraries. What happens if there's some 0-day in some library? You want to make sure that you're also checking that on a regular basis. And now there's two other topics that are usually forgotten. One is, what happens if suddenly there is a disaster and all your data is lost? You definitely need to think about it. And that's something that is minimum. Same thing when an incident happens. The question is not whether or not there will be a security incident. The question is when it will happen and will you be ready to face it? And to face it means basically that you need to be able to investigate what happened in order to remediate to the incident. So what are the controls in all those cases? Well, before that, let's see what Kevin did in the house. So the first thing he tried to do is slow the attacker down when they were inside a house. He was using an iron to try to knock Marvin down. He was trying to use a blowtorch for Harry, and then it didn't work, so tried a paint can. Everything to try to knock them down. So what should we do in our cloud? Well, let's see. I have some traffic. It's very easy and something that everyone should do. Encrypt your traffic, use HTTPS. There's no excuse not to use HTTPS for your application if you have public endpoints, for example. You have some secret, use a secret manager. Store all your secrets there. Don't try to reinvent the wheel and do it by yourself. We've been talking about the different services. Make sure that you use the least privilege. So if, for example, you have a microservice and you want to, and he needs some access to another service, you can grant them access to the service. But don't just like give it access to all the services. So if, let's say, I need access to a database, let's give them access to the database, but the second service doesn't need it, it shouldn't have access to it. And then you can reduce the blast of a possible attack. We're talking about libraries, dependency check. Seems like also a minimum today, right? Now, what about the data? It needs to be backup. And what about incident response? Well, at least you should have logging, because if you don't have logging, you have no idea what happened. So you should have two types of logging. One is logging for your application, and the second is logging for your cloud infrastructure. That means audit. That means they should be able to see exactly what happened if there was an attack. And that will allow you, first of all, to know what was the origin of the attack, was there a security hole, what was the path of the attacker when he penetrated in your cloud. Logging is really critical. Now, to give it in a nutshell, this is the list of the minimum security controls. And I try to put it on the map so that you would see the different areas, different layers. You start with your code, with the dependency check, down to your pipeline, and then you have all the different things that I've been talking about, from pen testing to check that you don't have any vulnerability, logging, encryption, least privilege, backup, everything should be there. Now, what I would like to do is to show you that in practice. We'll take a very simple application written in Python, and it's a microservice. You can look at it as a microservice. And we'll try to see how we can apply most of these controls, right? So the sample microservice we'll take is actually an API-based, it's fast API-based application that displays move information, very simple. And I took something like that just to show you how it's easy to add basic controls. Data persistency is SQLite, and we use GitHub and GitHub Actions both for storing the code and for the pipeline itself. And the goal is to add 7 tools in a few minutes to show you how it's easy to get starting with. It's not everything that I showed here, but it's already the beginning. And everything that we'll show is there is actually a repo that is public, so you can clone it, you can do it yourself afterwards. So let's get started. The first area is the code vulnerabilities, and for that, we'll use a SAST scanner. And for the demo, I actually use Bandit, which is a very well-known open source scanner in the Python community. It already includes about 35 rules for detecting the most common vulnerabilities. For secrets, we use GitLeaks. It's a great open source tool by Zachary Rice that allows you to detect the most common keys and tokens that are out there, from AWS credentials, AWS keys, from SH keys. There's a lot of regexes that are included in the tool, and it also searches throughout the GitHub, the Git history. For dependencies, we'll use a tool called Safety, which has 2 modes, one open source with monthly update and one commercial, and it can detect publicly disclosed vulnerabilities. For infrastructure misconfiguration, we'll use a tool, an open source tool developed by Checkmarks that supports many type of infrastructure. It can be CloudFormation, it can be Terraform. If you're into Kubernetes, it can also support Helm charts, Docker, Ansible. There's a lot of support, and it includes about 2,000 checks. So it's really a great tool, and we'll use it. Next thing, pen testing. We'll use a great tool by OWASP called Zap. And we'll use it in a special setup that I will explain in a minute. But basically, it includes a lot of built-in rules. It also knows how to scan APIs. So if you have Swagger, you can definitely use that. It will crawl all your API and make sure that you don't have vulnerabilities and reports everything. Now, in order to use it, what we'll do is that we'll build a container from our application. And then we'll actually use that inside our CI as a service, and then we'll run Zap against this container service. Since we're using containers, we also want to make sure that the base images of our containers are safe. And for that, we'll use Trivy. It's an open source also that allows you to check the packages and all your base images. And finally, I talked about MFA. And so you want a way to check that, for example, let's say in this case, that your GitHub service has MFA enforced. So there's not really a tool for that. So I'll show you that in a few lines of code, we can build our own tool. And this is what we'll do here in this example in order to check that MFA is enforced at the level of their organization. So if I summarize, these are all the tools that we'll use in this demo, from SAST to infrastructure as code, SCA, containers, DAST with Zap, and MFA, which is custom. Okay, so now let me show you some code. First of all, let's see the application in practice. So this is my terminal. This is actually my code. Let's start. It's using UVcorn. Okay, I'm starting the API. So you'll see that basically the API is a few endpoints. I'll show you the endpoints quickly. There's a movies endpoints. So it returns a number of movies. I can check for a specific movie, for example, Titanic. And there are 3 results. I'm interested in this one, which is the one that is the most popular one. And what I want to check is what stars were in this movie. Okay, so these are the stars. Okay, a very, very simple application. Let's now see the code about it, the code of this application. So, this is the code, very simple. It's a SQL. You can already see for the ones that have good eyes that there are a lot of SQL injections possible here. But basically, this is the code. 4 different endpoints, very, very basic. Let's put it like that. The guy who wrote it didn't think about security at all. There is the Docker file. Here, again, in the Docker file, you can see that though he used official image, there are some environment variables for the secrets in order to get access to AWS. Definitely not something you should do yourself. So we also scan this Docker file and this image. There's also a little bit of Terraform here, just creating a bucket, an S3 bucket. So really basic stuff. And what I want to show you is actually this GitHub workflow, which is the CI part, and how you can integrate those tools very easily. So most of the tools that I showed you actually have a GitHub action that is already packed. So you don't need to do a lot of things. That's the advantage of using GitHub action in both those tools. So as you can see here, for example, with Bandit has already an action for that. So the only thing that I needed to specify is actually the configuration of the tool. which here I want the output in a file, and then I want to upload that as an artifact in GitHub Actions so that I will be able to review the results. For the secrets, there is this git leaks action that is also built in. And the nice thing about this action is that it's automatically exiting with exit code 1 when it fails, when it finds some secrets. So we'll see that in action in a second. For Dast, so we used Zap here. And so what I did is I built the Docker image. This is what you saw before. And I'm making sure that the image is actually live and it's working with the health check before it actually is starting the action. And the step is really easy. Zap is also an action that is built in. I'm using here the Open API. So Open API allows me, this is something I'm getting automatically using Fast API. I'm getting automatically this API documentation. And so I can provide that to Zap so that it can scan the different endpoints automatically. Let me show you just one sec what it means, what you get there. So if I'm going to open API JSON, you'll see that this is the documentation of the API, right? And so here for the infra, I'm using Kix. Kix also has a GitHub action. I just need to configure where's the Terraform part. And this is the part where I want my results. And I want to show that inside the log. And then for SCA there's no action, but it's really easy to just install a Python package inside GitHub Actions. So this is what I'm doing here. And then I'm just checking the requirements.txt, and I want the output in JSON format. And at the end, the container, and for container scanning, I'm actually building here the image, and I can run Trivi, which has also his built-in action, against the image that I built. And I want only to see critical and high here. Right. At the end, I'm looking for MFA. Here, I wrote a few lines of JavaScript just to check that when I'm getting this list of member, everyone actually has MFA, and there's a filter for 2FA disabled, because I want to see if there's at least one user that don't have MFA enabled. Okay, so this was the code, and now let's see in action inside GitHub. So this is the repo that I talked about. Everyone can see the full source, including what I just showed. So if you want to play with it, you're welcome to. And I already created a pull request here, very simple pull request, and you will be able to see that, well, all the checks are failing here. So this is definitely not a great application. If I'm looking at the checks themselves, I can check here. So I can see all the results. So this is in GitHub Actions. I can see that Zap, for example, is outputting a lot of things, all the tests that pass and the one that does not. So you can see that there's an issue. It also outputs here a full report in issues automatically. You can see here the issues that it found. Some other tools, so let's see that in action. Some other tools are actually, so you can see here, this is the results. Some tools are uploading some artifacts, so I can download it and check the results, all the findings. And some are just writing their results inside, just like here, inside the action itself. So it's not really great in terms of experience. I'll get back to that, but basically it's usable. If things are not working, it will stop my PR and I won't be able to merge it. Okay, let's go back to the slides for a moment. Okay, so what I just showed you here is a simple way to integrate all those different tools in your CI pipeline. And you can see that though the experience is not great, it's actually not that hard to integrate those very basic tools, and that already gives you some really good hygiene in terms of security. It already covers a lot of risks, right? So if we're coming back to the suggestion for the minimum viable security, because there's not really a standard for that, at least not yet, this is what I would say. You have 8 different areas. You have your code. You need to check for vulnerabilities, secret logging, and your dependencies. In your infra, make sure that you're running some kind of tool for about misconfiguration, and you have least privilege remote access, so try to manage the access of your users. For your runtime, do some pen testing and API security. We did that with Zap. For your pipeline, check your Docker images when you build them, and least privilege access for your whole pipeline. For your data, you want data encryption and storing your secrets. For your third party, make sure you use MFA and you have a secure access. For your people, something that we didn't talk about, but of course seems like basic password manager. And finally, for your operations, make sure you have audit and backup in place. Now, I think that for security, one aspect that shouldn't be ignored is the experience. And as you saw just before, the experience wasn't great. And if the experience is not great, you cannot expect from developers to handle security and not be pissed about it. Usually they're not really happy to take care about security because the tools are not really dev-friendly. And so what I would suggest is, first of all, try to see if there are some dev-friendly tools, and they should be the one who are the owner of the tools, because that's the only way it can work. Like QA in the past, there was a different team that is outside of engineering. There was a lot of frictions there. And finally, the best way to improve efficiency was to try to put QA inside the team. And the same thing should happen for security. Security shouldn't live outside of engineering. It should be part of the whole chain of creating your application. If you have microservices team, and the team is responsible of building the application, deploying the application, testing the application, supporting that in production, it doesn't make any sense that they're not also the ones that are responsible for securing the application. Makes sense, right? And so how we can help the engineering organization with that? Well, this is basically our mission at JIT, and this is what we tried to do. We want to provide, first of all, a way to manage security plans in an automated way so that it can continuously monitor your application for security risks. And it should start with something minimum. It should start with the MVS that we're talking about. And then as agile methods are, that we're using today, we should iterate. So you should start small and then iterate for more than that. So this is what we are providing. And also we want to provide a dev native experience. So instead of just having your findings scattered all over the place, we're actually managing to put all those different findings inside GitHub, inside the PR itself, so that it will be part of the workflow of the developer that is right now checking for reviews. And that's why it looks like a peer security review. And also that's the reason we're called ourselves JIT, just in time, because we want to provide the context of the security issues to the developer just in time for him to fix it and not to be an overhead. And so you would ask yourself, okay, I did everything that was there, great, but wait, did I finish? That's it? Security is only the eight different areas that I showed? Of course not. Security is a never-ending journey. And what I demonstrated here was only the first part of the journey. It's the MVS. But the MVS is not the end. And that's why when I'm talking about minimum viable security, I'm not saying that it should stay the same. In the same way that Kevin's parents cannot rely on him, on his booby traps forever, and the more there is some valuable things in the house, the more you want to beef up your security, here is the same. You can start with something small, especially when you're starting something, when starting a new project, but of course shouldn't remain that way. You should iterate every time with more security. You'll be more mature in terms of security, and then you can go to the next step. So there's more advanced plan, of course, with way more things you want to do. You can even think about compliance afterwards. There are way more things you need to do. And if you're thinking, okay, what should I do next? Well, that will be the topic of my next talk. Just like there was a second movie in Home Alone 2, I'll be there for the next talk. Thank you very much for your attention. If you have any question, I'd be happy to answer. And if you're intrigued about what I showed here, well, basically, you're welcome to try our free beta at g.io. If you're inspired by what you heard and you want to join the mission of helping developers secure their own product, then you're also welcome to join us. And I'm happy to take any question if you have some.
I have two questions. One, will you post the presentation somewhere?
Sure. Yes, I will post the slides, and I will also communicate in the Slack. I'll post the slides. Yeah, in Slack I'll post the slides and the address of the repo. Yeah, sure.
And that also answers my second.
Yes.
Thank you.
I will.
Question.
Sure.
There's a lot of Azure in the teams I work with. If you do this for that kind of cloud, how much changes would you need before it works?
So basically, I would say that if you're using what type of clouds?
Azure.
So for Azure, I think that most of the tools that I showed actually are the same. The things that are code related, of course, are the same. I think that Kix that also supports Azure. I don't think I showed something really that was AWS specific here. So it was mostly a concept. I took AWS as an example and thinking about buckets and things like that, but the concepts are actually the same for every cloud. There wasn't something here that was specific to AWS, I believe. So it should be fine. Should be able to use all those tools and more. Awesome. Thank you very much.